contract module. The contract module provides functionality for the runtime to deploy and execute WebAssembly smart contracts. Call config error event overview. This module extends accounts based on the currency tray to have smart contract functionality. It can be used with other modules that implement accounts based on currency. These smart contract accounts have the ability to instantiate smart contracts and make calls to other contract and non-contract accounts. The smart contract code is stored once in a code cache, and later retrievable via its code hash. This means that multiple smart contracts can be instantiated from the same code cache, without replicating the code each time. When a smart contract is called, its associated code is retrieved via the code hash and gets executed. This call can alter the storage entries of the smart contract account, instantiate new smart contracts, or call other smart contracts. Finally, when an account is reached, its associated code and storage of the smart contract account will also be deleted. Gas. Senders must specify a gas limit with every call, as all instructions invoked by the smart contract require gas. Unused gas is refunded after the call, regardless of the execution outcome. If the gas limit is reached, then all calls on state changes, including balance transfers, are only reverted at the current call's contract level. For example, if contract A calls B and B runs out of gas mid-call, then all of B's calls are reverted, assuming correct error handling by contract A. A's other calls on state changes still persists. 1 gas is equivalent to 1 wait, which is defined as 1 picosecond of execution time on the runtime's reference machine. Notable scenarios. Contract call failures are not always cascading. When failures occur in a subcall, they do not bubble up, and the call will only revert at the specific contract level. For example, if contract A calls contract B, and B fails, A can decide how to handle that failure, either proceeding or reverting A's changes. Interface exposed to contracts. Each contract is one WebAssembly module that looks like this. Module, invoked by pallet contracts when a contract is instantiated, no arguments and empty return type, func, export deploy, semicolon invoked by pallet contracts when a contract is called, no arguments and empty return type, func, export call, semicolon if a contract uses memory it must be imported. Memory is optional. The maximum allowed memory size depends on the pallet contract's configuration. Import env memory, memory 11, semicolon. This is one of many functions that can be imported and is implemented by pallet contracts. This function is used to copy the result buffer and flags back to the caller. Import seal 0 seal return, func $seal return. Param I30 to I30 to I32. The documentation of all importable functions can be found here. Look for the define env macro invocation. This module executes WebAssembly smart contracts. These can potentially be written in any language that compiles to WebAssembly. However, using a language that specifically targets this module will make things a lot easier. One such language is Inc, which is an edsel that enables writing WebAssembly-based smart contracts in the Rust programming language. Contracts can emit messages to the client when called as a PC through the seal debug message API. This is exposed in Inc via Inc debug message. Those messages are gathered into an internal buffer and sent to the PC client. It is up to the individual client if and how those messages are presented to the user. This buffer is also printed as a debug message. In order to see these messages on the node console, the log level for the runtime contracts target needs to be raised to at least the debug level. However, those messages are easy to overlook because of the noise generated by block production. A good starting point for observing them on the console is using this command line in the root directory of the Substrate repository. Cargo run, release, devlera, runtime, contracts equals debug. This raises the log level of runtime, contracts to debug and all other targets to error in order to prevent them from spamming the console. User dev chain spec, TMP, use temporary storage for chain data. The chain state is deleted on exit. Driven by the desire to have an iterative approach in developing new contract interfaces, this palette contains the concept of an unstable interface. Akin to the Rust nightly compiler, it allows us to add new interfaces but mark them as unstable so that contract languages can experiment with them and give feedback before we stabilize those. In order to access interfaces marked as unstable in runtime OS, one need to compile this crate with the unstable interface feature enabled. It should be obvious that any live runtime should never be compiled with this feature. In addition to be subject to change or removal, those interfaces do not have proper weights associated with them and are therefore considered unsafe. The Substrate runtime exposes this feature as contracts unstable interface. Example commands line for running the Substrate node with unstable contracts interfaces. Cargo run, release, features contracts unstable interface. Dev new interfaces are generally added as unstable and might go through several iterations before they are promoted to a stable interface. License, Apache 2.0.